Okay. All right. Let's have the review out. If you have your review, let's see it. What numbers are you on the review? 18 through 30. Thank you. All right. So, let me just write these down real quick and I'll come back and work them out. Let's see, negative 4k plus 5 is less than or equal to 21. Then number 19. And then 20. What do we go up to? 30?
Yeah.
Okay. All right. Okay. Thank you, John. All right, so this has all been recorded, so at least review. This is up to number 30. Let's make sure we do it. Remember, I'm not collecting the review as we go through the days of the review. You get points for it. Okay, so problem number 18. We want to put it on a number line. Is that correct?
Yes.
It's multiple choice on the number line. All right, so I want to solve number 18. I want to get k by itself, so I need to subtract 5 from both sides. So I get negative 4k is less than or equal to 16. Divide everything by negative 4. If I divide by negative, what happens to the sign? Flips it over, right? So take a look at how that sign flipped from here to here. It's because I had actually divided by negative. If I put this on a number line, you have negative 4 here, you have 0 here. This is a closed dot, and it's shading to the right. Is that right?
Yes.
If you didn't have the equal sign, it'd be an open dot, correct? Number 19, they just want us to put it in notation, right? So square bracket or parentheses. So let's solve it. So, and then divide by 2. So I want values bigger than 9. Do I include the 9? No, it's not included. I don't have an equal sign. So the notation I want to put is parenthesis from 9. That indicates it's not equal to it. It gets real close to it. It's like 9.0 going forever with a 1. And then we go to infinity. And remember the infinity, you never have a square bracket because you never get there. Yeah.
So we don't know how to get to infinity.
It's a limit that we approach, but we can't get to it. It's not a number. It's kind of like saying, can you take half of any fraction? Yeah, just double the denominator. But you'll never get to 0 because you can always double the denominator. Same thing, you can always continue towards infinity, but you can't get there. What's the biggest number? I don't know. Big. More than I want to count. This particular problem, oh shoot, it's a 26 plus 6b. I can't read my line. Okay, thank you. So I'm going to distribute here. So I have 26 plus 6b is greater than or equal to 6b plus 8. Is that okay so far? If I subtract 6b from both sides, those cancel. So I wind up with 26 is greater than or equal to 8.
True statement.
It's a true statement. So what can you say about 26 is indeed greater than 8. So what can you say? All real numbers. It's a true statement. If it was a false statement, there would be no solution. So this is going to state that all real numbers work. Did they want this on a number line? So the whole thing was colored, so on the number line it just kind of looked like this. Like that. Is that okay? Cool. 21. It's an and statement. The and statement shades where, how?
Between.
Between. Good. The and shades between. So and might be this way or it might be put together. So I do the two problems that are listed. Divide by 5. So I get that. And then add 7. 7x is less than or equal to 21. Divide by 7. X less than or equal to 3. Okay, so let's draw our number line. We have 0, 1, 2, 3. Agreed? Solid dot?
0.
At 0? Solid dot at 3?
Yes.
Where am I shading?
Between.
In between. It's an and statement, so it shades in between. The or statement is shading opposite ways. It doesn't shade in between. Okay? 22. What kind of statement is this? Is it and or or? When it's put together, it's an and statement all the time. Okay, you don't have an or statement that goes together. Okay, so how many problems are listed up here? 2. I have this as one problem, and then I take the middle. The middle gets written twice. So I have 2 different problems that are written up there now. Good? Go. All right, so let's solve both of them. So this one, I'm going to add 4 to both sides. That gives me 2 is less than or equal to 2x. Divide by 2. 1 is less than or equal to x. If you leave it like that, you can put it back together at the end. Is this graphing or no? Is this problem going to be graphed?
Yes.
Okay. So being it's going to be graphed, I'm going to flip this over. Okay? I'm going to add 4 here. Divide by 2. All right. Number line. 1, 2, 3, 4. There's a 0 here. Open dot at 1 or close dot? Close. It's equal to it, right? Open or close dot at 4? Open. Where do I shade?
Between.
Between. Done. Good so far? just want this in notation. It's written in and form. It's combined together. Break it into two problems. Remember, the middle goes with both. Let's see. I'm going to add 5 here. That cancels. That gives me 1 is less than or equal to 1 half x. Multiply both sides times 2, or 2 over 1. That cancels. Bless you. So I'm going to flip that over. Get that? That cool?
Yes.
And then on this one, I'm going to add 5, add 5. Less than 10. Multiply this side by 2, or 2 over 1. We're doing this as notation, so we're not graphing. So where am I starting? At 2. Where am I going to? 20. Did I start at 2? Did I include 2?
Yes.
Yeah, it's an equal sign, so it's a square bracket. I ended at 20. Did I include 20? No. Rounded bracket here. There's your answer. Cool? 24. We have the function at x, f at x, or f of x, depending upon how you want to say it, is equal to 2x minus 3. F at x is the same thing as saying y equals. What am I going to do with this 4?
Plug it in for x.
Plug it in for x. So this is going to be 2 minus 3. There was an x here. What's going to go there now? 4. So 8 minus 3, that gives me 5. Okay, so this is the actual answer. If I wanted the point, what point would this be as an ordered pair x comma y? If I wanted to write this as a point, it would be listed as 4 comma 5. You plugged 4 in for x, the output was a 5. What about this second problem, 25? F at x equals 2x minus 3, and then we know that function at x is equal to 13. Am I plugging 13 in for our x value? No. Notice up here, I plugged 4 in because this was function at 4. This is still function at x. So what should I plug? Where should this get plugged into? Yeah, it should get plugged into right here. So I get 13. Notice it's not function at 13, it's just 13 equals 2x minus 3. Add 3 to both sides. So that's 16 is equal to 2x. So x is equal to 8. Okay? What point would this be?
8 comma 13.
Yeah, the point on this one would be 8 comma 13. Okay, and I don't know if it asks for the point or if we just wanted the answer. I'm not sure. I'm not looking at the paper. I'm just trying to work out the problems. Does that make sense? So it's done 2 different ways. So if it says function at, and there's something that we're plugging in, plug it into the x. If they tell us that we have function at x equals this, and then function at x is equal to something else, set them equal to each other and solve it. 26, g at x means the same thing as f at x, same thing as y. What am I going to do at g at 0?
Plug 0 into 2.
I'm going to plug 0 in. This had been x. What's going in there? 0, so I get 0 squared plus 10. What did I do? Am I okay? And then, so again, that would have been the point 0 comma 10 if it asked for that. Number 27, I'm plugging negative 1 in for x, so that I have negative 3 minus 12. There had been an x there. I'm going to plug negative 1 in. So it's going to give me 3 minus 12, which is negative 9. The answer to that is negative 9. The point would have been negative 1 comma negative 9 if they'd asked for the point.
I like the next 2 problems.
Oh, cool. The y-intercept. So 2 different ways you can do it. You could solve the whole thing for y, correct? Or I could cover up the x value. So what's y equal to?
Negative 5.
Negative 5. So what's the y-intercept? It's 0 comma negative 5, or it could have been just negative 5. I don't know how they do b equals. I don't know.
You just had negative 5.
Just negative 5? Okay. That works. 29. What is the slope of a horizontal line? Horizontal gives us a slope of 0. I don't know if they had m equals 0 or just 0. Vertical line is what for a slope? Undefined. Undefined is not a numeric value. It's just undefined. The word itself. And then 30. For this one, they wanted the slope and the y-intercept. So this one, you might want to say, hey, let's go ahead and solve for y. So y equals negative 3x plus 7. We know that that's now set up in slope-intercept form. So whatever's attached to the x, once we solve for y, is our slope. So what's our slope? Negative 3. What's my y-intercept? 7. So if you wanted to put it as a point, it could be 0, 7. Again, I'm not sure how they had it represented. Just know the difference. Good? Happy there? All right. Let's see. We had homework came out of our report or notebook, right? What page was our homework on? 157, 158. So if you would, get page 157, 158 out. I'm going to come by and do a quick mark on it. Got it out? Have it? Okay, cool. Mr. Stroud, will this new stuff be on the file? Okay. Sometimes strawberry. Let me know when you get around. I'll come back. Will this be on the final? Cool. Me too. Okay. Yep. That's it? I'm going to register at the top. Cool. That's just a note to me.
Well, I'm gonna do it.
No, I know you are. But I just want to make sure you get points for it.
Oh, yummy.
Thanks. Ma'am's good. She's on. You must be question. You still love
You did like my brother at the grocery store. It's just that I said, you just farted. I yelled it out in front of everybody.
All right. Let's run through the assignment. 157, 158. Get mine out real quick. There we go. All right, any questions on 1, 2, or 3? 3? Okay, is there one of the problems, top or the bottom, that we have solved for one of the letters? The bottom is solved for x. Agreed? X equals. So I'm going to take this x equals value, and I'm going to plug it right in there. Okay? So I'm going to get 1/2 y plus 2, and then minus y equals 1. I don't really like fractions, so rather than moving things around, I'm going to multiply everything by what number to get rid of all the fractions? 2 over 1 or just 2, okay? So that cancels. That gives me 1y or y plus 4 minus 2y equals 2. Is that all right? Combine the like terms, so I get 4 minus y equals 2. Subtract 4 from both sides. So y is equal to positive 2. Am I done with the problem?
No.
No. What should I do with that value? What value am I looking for? I'm looking for an x. Okay, and I have a y value, so I can either plug it in here or here. It makes more sense to plug it into this one. Why am I saying that? It's already solved for. It's going to be the same answer regardless. This had been a y, but we know that y is 2. So what's half of 2? 1. So 1 plus 2 is? So if this had been graphed, it would have intersected at 3, 2, but the solution to this problem is 3, 2. In order to check it, I could plug that x and y value back into both the equations, and it'll give us true on both. Yeah.
So what I did was I added y on the top equation.
Good. And then you substituted in for x on the other?
Yeah, and I got my answer was way different. I got 2.
Then you did it wrong. Then you did it wrong. You did a mathematical error someplace.
4.
Which one, 4?
Yeah.
Yeah? Okay. Ram, if you did it that way, you should have gotten the same answer, so you just made an error someplace on it. All right, is one of the problems, have I solved for a letter on one of the problems? Which one, the top or the bottom? Top one, we know that x equals this. So I'm going to plug that in for x right there. Is that okay?
Yeah.
So I get 2y plus 5 equals 35. That was x. Now I'm going to plug 3y minus 27 in. Okay? Distribute here.
15y.
Minus 135.
135 is, okay, thank you. Is that all right so far? Let's combine like terms. So that's 17y minus 135 equals 35. Add 135 to both sides. Is that 170? So we find that y equals 10. Is the problem done yet?
No.
No, what should I do with that 10?
Plug it in for
Where?
y.
Plug it in for y. So I can plug it in here, or I can plug it into here. Which one makes more sense?
Top one.
Top one. It's already solved for x. I'm looking for an x value. That was a y. Now I'm going to plug a 10 in. So x is equal to 3. 3, 10 is our answer. Okay. What else from that front page?
Number 6.
6. All right. Of my two equations, do I have a letter solved for one of them?
Yes.
The first one or the second one?
Second one.
Second one, I know that y is equal to this. So I'm going to plug that value right in here. Gotcha? I get x minus 2 parentheses equals 10. That was a y. I'm going to plug that in. Okay, distribute the negative 2. That's what? 7x equals, if I add 36, 46. Is that a fraction? X equals 46 over 7. Ew, yuck. Okay, make sure it's reduced. It is reduced. You could make it improper, or you can make it mixed number. I'm going to keep it like that. That's how I roll. That's an x value, right?
Yes.
So I could plug that in, that x value in right there. I'm going to get y equals negative 3. That was an x value, but I'm going to plug 46 over 7 in. Oh my gosh, are you kidding? All right. Okay, so what is negative 3 times 46? Someone with a calculator. Negative 3 times 46. Negative 3 times 46.
Negative 138.
Negative 138. Oh my gosh. Alright, put that over 1. So I get y equals negative 138 over 7 plus, I multiply that by 7 over 7. What's 7 times 18? 126. So negative 138 plus 126 is negative 12. Oh my gosh, I get negative 12 over 7 for my y value. I will tell you this, that would have been an ugly one to graph. You wouldn't have found that point real easily. And that's, again, why substitution works well.
Is there going to be anything like
Yep.
this on the final?
Absolutely.
Oh.
Okay. Then there won't. Then just skip it. Right. I'm just saying. Right. I don't know. I probably won't give you a decimal or a fractional amount like that. I bet you they'll all work out nice enough. Final shouldn't go real deep in the content. It should just brush over all the content. Any other questions from the front page? 11. I'll just do 10, 11, 12. Okay? Number 10, 11, and 12. If a system has one solution, write a system of two linear equations that have one solution. Y equals 3x plus 4. Y equals 5x minus 7. How do I know that has one solution? Is it parallel? No. It's not parallel. It's going to cross. Right? So this would cross at x comma y someplace. What's my x comma y value? I don't know. I'm not going to solve it. Didn't ask for it. System has no solutions. That means their lines are parallel. They're not the exact same line, are they? Same slope, different lines. Okay, so these are parallel. So these are parallel lines. And then if I wanted to write a system that has infinitely many solutions, exact same line. Infinite solutions. Good? Anyone want to see 13, 14, or 15? This is going back to graphing. 13 done. Do it. So I get 2x minus 3y is equal to 12. Y equals 2x plus 4. Okay? I'm just going to draw it out rather than pull it up. Cover method here, that looks like 6. Cover method here, that looks like negative 4. Okay, this one, my y-intercept is positive 4. My slope is up 2, right 1. Somewhere down there it's crossing. Do I know exactly where? I don't know. I didn't graph that nicely. This would be a great one to do substitution on, obviously. I'd say plug that in right there. Negative 4x equals 24. X equals negative 6. And then plug that value in here. Can you justify making negative 6? 3, 4, 5, 6, negative 8, 5, 6, 7, 8. Work?
So do you always have to use a substitution method? Or can you?
I just used graphing on that, but graphing didn't work out too well, so I used substitution to figure it out. Why does graphing not work? Because I can't freehand draw perfect.
But you can do the graph.
You can, but you're not always going to find it. So could you have found negative 6 comma negative 8 on a graph with a ruler? I think so if you graph totally appropriately. But where it gets goofy is, look at that intersection.
Right.
That's,
You're
yeah,
not
What do you got, Joe?
For the final, is there going to be like,
I don't know.
how the graph?
Don't know. Haven't seen it yet. I don't know. I honestly, I have not seen the final yet. I haven't looked at it. So I can't answer your question. I'm sorry. I wish I could. I'd say it's going to look very similar to what this review is. Very similar. Okay, we're going to have multiple choice. a lot of it. Some of it might be short answer. That'll be Monday. We'll take short answer. All right. What else from the backside? 16. Length of a rectangle is 4 more than twice the width. Okay. Okay, rectangle. So I know if I have a rectangle, the area is equal to length times width, and the perimeter is equal to 2L plus 2W. Okay, so those are the two equations that should be in your back pocket on this. And they tell us we have the length and we have the width. So there's some relationship between the two. The length of a rectangle, the length of the rectangle is 4 more than twice the width. The length is 4 more than twice the width. That's the relationship. I don't really need this one right now because that's the relationship I'm looking for. Length is that. Width is just going to be W. Okay? Let W be the width. Okay? What is, okay, the perimeter is 44. So if I'm going to use this equation, 4 equals 2L. I know L is this, plus 2W. W stays as is. I'm going to distribute here and here. Was that 4W? Sorry. I subtract the 8, so I'm going to bring that over. That's 36 equals 6W. So the width is equal to 6. And then if I wanted to find the length, I'm going to plug that in there. So that's 4 plus 2 times 6. So that's 4 plus 12. So the length is 16. So I have a length of 16 and a width of 6. What dimensions? Find the dimensions of the rectangle used in the system of equations. We're good. No, we're done. Cool? All right, I'm done.
Wait, is there going to be like any questions like 16 on the final?
Yes. To answer your question. Did you not hear what I just said to Joe? So now the answer is just going to be yes nonstop. If you didn't hear what I said to Joe, go back and look at the video. Joe, tell him.
Yeah.
I haven't seen the. I haven't looked at the final directly. I haven't gone through point by point by point to say if it's there. I'd say if it's going to be on the review, which you have that packet, it's going to be on the final. Cool? All right. Pass those in. Make sure your names are on them, please. What's a really good way to work on the final? Do all the problems that you know how to do first. Do them well, get them right. Go back to the ones that you're not sure of. That is the best advice I can give you for final. What happens to kids all the time during the final? They go from 1 to 50, or whatever many numbers are on there, in order, and they get hung up on number 37. Even though number 38 is the easiest problem in the world, they're so hung up that there's one problem that they can't do, and they're panicking. Do the problems that you know how to do first, and do them well. Don't stress over going, oh, there's that one tough problem. If you do that, you're going to get hung up, you're going to run out of time. It's not a good way to do it. Guys and girls, it's pretty rare for students to get 100% on the final. Now, I'm not saying that because I'm a mean teacher. I'm just saying it's not something that is happening often. Okay? It's pretty rare that students ace tests in every subject every day. Okay? It's okay. That's how it is. It doesn't mean that you're a bad kid. It doesn't mean that you're not going to be successful in life. You're going to be very successful. You're going to have beautiful kids and beautiful animals. And you're going to come back and say, dude, I did it. This is awesome. But don't panic if you get to a problem on the final that you're like, I don't know how to do this. Good. I know. Move on. Come back to it if there's time. If there isn't, I did the best I could. Right? Yeah, but I need 107% to get an A in the class. You're not going to get an A in the class. But yeah, you're not going to get an A in the class. Yeah, but if 107%, the best you can get is 100%. Yeah, but if I get 107, you won't. It's impossible. There's not extra credit on the final. You're not going to get the 107%. Got it? Well, that's mean. Yeah, I know. It's real mean. It's real life. All right. This is part B. Let's move on. Solve the following. What should I do on problem number 1? What do you think? I want to solve it.
Substitute y.
Yeah, so I am going to plug in. Let's go to highlighter. Highlighter, come on up. I'm going to plug this in where? Into the y on the other equation. Is that all right?
Yes.
Everyone with me? So I'm going to go 2x minus 3. There was a y there, but now I'm going to put 2x plus 5. I'm going to distribute here and here. Is that all right? Again, it's the same stuff we've been working on. Add 15. Divide by 4. Am I done? No. I want to plug in this value here. Okay, I could plug it in here as well, but the top one makes sense because I'm looking for a what value? I'm looking for a y. I already have an x. So I have y equals 2 times negative 5 plus 5. Y equals negative 10 plus 5. So y equals negative 5. Oh, cool. They're the same thing. So I get negative 5 comma negative 5 as my answer. If I plug negative 5 back into the original problem, I'd get true and true. Okay? If I plug negative 5 into this, I get negative 5 equals negative 10 plus 5. Negative 5 equals negative 5. Woo! If I plug it in here, I get negative 10 plus 15. It's positive 5. Works. Okay? Second problem. What should I plug in where? Yeah, I'm going to plug this right here into right here. Okay? So I get 8x minus 2. That was a y value, but I'm going to plug 4x minus 1 into it. I'm going to distribute negative 2 both here and here. What do you notice right now is going to happen? Huh?
Oh, the x is going to cancel out.
Uh-oh. So these are gone. I wind up with that. That means infinite solutions. Awesome. Okay? These are the exact same equations. One of these just has to be in standard form. The other one happens to be in slope-intercept form. So I got a true statement that fell out. All of my x's or all of my y's fell out, and it gave me something that's true. That means infinite solutions. Same line. If you graphed it, it lies one line on top of the other. Is that all right? So what do you think is going to happen on homework tonight? So, that kind of stuff, right? All right, number 3. What should I do? Plug the y in. So, again, my highlighter, plug that in right there. Okay, so I get 3 parentheses plus 3x equals 12. I'm going to plug negative x plus 8 in. Distribute here and here. What do you notice? The x is canceled. This and this, they're gone. So I wind up with 24 equals to 12. I did not figure out the great mystery in life that anytime you have a 24, you can plug 12 in. No, this is nonsense. This doesn't happen. This means there's no solution. What kind of lines would these be? They would be parallel lines. They wouldn't intersect. Okay? Number 4, I need to get one of the values. I need to get x by itself somehow. Yeah, so if I modify this one by subtracting 2y, does this change into this?
Yes.
Cool? What does that mean? That means I'm going to do this. I'm going to take that right there. I'm going to plug it in right there. So I get 2 parentheses minus 3y equals 13. I'm plugging in 10 minus 2y. Distribute here and here. 20 minus 4y minus 3y equals 13. Are the y's going to cancel out?
No.
They just wanted to show you how you might have to modify it. So 20 minus 7y equals 13. Subtract 20. So I get negative 70, y equals negative 7, so y equals 1. Problem's not done yet. I need to plug that y equals 1 back into one of the equations. So I could take that highlighter, I could plug y equals 1 in it right here, or I could plug it in right here. Is there one other place I could plug it in?
X equals 10 minus 2.
Yeah, right here. Remember that one? Oh, that's ugly. You can't do that. I can plug it in right here. Why is that? Why do you think that works?
Because it's already solved for X.
Yeah, I already solved it for x. So what did y equal?
Negative 1.
Y equals 1. So if I plug 1 in, 1. 10 minus 2 is 8. So my solution is 8, 1. Good? Remember, 3 cases. One solution, you get x, y. Agreed? It means they cross. They could be perpendicular, which is fine. They're going to cross. 0 solutions, you get a false statement. You get like 5 equals 3. It's nonsense. And then infinite solutions is a true statement where you get 5 equals 5. Okay? So, guys and girls, we are still continuing on our adventure of math, right? So tomorrow, we have a quiz over these. We also have number 2B, which is page
159 probably.
Page 159, would you think?
Yeah.
Is it 159, 160? I don't know. Is there a front and back?
Yeah.
Okay, cool. And then, there's Schoology, right? There's a big review on Schoology. We have gone up through what number? We've gone up through number 30 on the review. So remember, there's Schoology. That closes when? Sunday. And then your review packet, we will go over 31 through, let's go 31 through 39. Gotcha? Yep, we'll go over, make sure we cover that tomorrow. Cool? 31 through 39. Cool. I'm going to do that. We good? Everyone happy? Quiz tomorrow. Page 159, 160. Yep. There is a thing on Schoology. Good. We covered it. I'm done.